And we're back on the air. Okay, let's table number 8 for now. This is the question that they gave us. Let's do an easier version to show you the technique. Then we'll redo this. Sort of rushed this yesterday. I don't want to rush this. So let's take an easier version. What they wanted was, what's the sum of the first n perfect squares? Apparently, it's a cubic. If you FOIL this out, you get an n cubed somewhere. They didn't tell you which cubic. I'm telling you what it is. So we can prove that later. Okay. Let's prove something easier, something that you know already. What's the sum of the first n positive integers? You know, because this is arithmetic, right? Isn't this arithmetic? This isn't. That's what's weird, right? This one's hard. But I'm going to come up with a new way of figuring out this sum that can work here. All right, so how do you add up n, the first n positive integers, if it's an arithmetic sequence? How do you do an arithmetic sum? Remember the rule for the finite sum of an arithmetic sequence. A sum of a finite arithmetic sequence. How do you do it? Right, so n being how many you got, right? Okay. N times the average of the first and the last. Well, what's the first? And the last? And how do you average stuff? Add them up and divide by 2. All right, so this is a simpler rule, but it has a lot of the same structure, right? There's a product in here. It could sort of be a FOIL type problem. This one's over 6, this one's over 2. You can get them in a similar way. Now, we've done this like 500 different ways. Let's do it a new way, okay? Now, let's do it the way that they said. Go right into question 8. And it says, what does it say in question 8? Where is it? Question 8 says, derive the formula for 1 squared plus 2 squared up to n squared. Hint, 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 make it a cubic. A n cubed plus b n squared plus c n plus d. All right. Hint, hint, hint. It's not cubic. What is it? What if you FOIL this out or distribute the n's? You get a what? What's the highest degree? N squared, don't you? All right, so we're going to do the same thing that they said. I'm going to write it like this, but for this problem. Ready? Okay, using their technique, this problem turns into 1 plus 2 plus 3 plus 4 plus all the way up to n. It's a finite arithmetic sequence. Equals a n squared plus b n plus c. A second degree expression, or quadratic. If you can figure out what a, b, and c are, you can figure out this rule if you don't know it. Okay? That's what we're going to do. We're going to figure out, in this case, we get a cubic. So we've got to figure out a, b, c, and d. If we figure that out, we're going to show that it's this. Or I'm cheating. I'm telling you the answer. But let's see if we can prove it, right? We know this answer too, right? All right, so let's do what they said. Now go on to their technique. Continue with what they said. It says hint. Plug in 0, plug in 1, plug in 2, plug in 3. All right. Now, they stopped at 3 because we want a cubic. We're not going to stop at 3 because we want a quadratic. We're going to stop at 2. All right, so let me do it backwards. Let me plug in 2. Okay? All right, here we go. Now, this is all commentary at this point. Whoops, not there. Okay? If I plug in 2, that means I'm adding 2 terms, right? So, what should I write? 1 plus 2 equals, now plug in 2. What's 2 squared? So 4a plus, plug in 2. What do you get here? Plug in 2 for n. 2b plus c. Okay, do it again. If I plug in 1, I'm just adding 1 term. So what should I write? 1 equals what? Now plug in 1 for n here. What do you get? A times 1 squared is 1 times a is a, right? B times 1? B. All right, so I get a plus b plus c, right? Whoops. All right, do it one more time. The problem is I have 3 things I don't know. I don't know A, B, or C. So I need 3 different equations that involve A, B, and C, okay? what's my last equation going to be? Well, I plugged in 2. I plugged in 2. I plugged in 1. Now, if you add up 0 terms, what do you get? You get 0. Okay. I think that's where people actually got stuck yesterday. 0 equals what happens when you plug in 0 terms. So plug in 0 for n. This all zeroes out, right? And this too. So what's the total? Well, 0 plus 0 plus c is c. So we know c already. That makes it easy. All right. Now, you could almost do this in your head. If you know c, you know that a plus b is 1. And you know that 4a plus 2b equals 3. Now, isn't that just solving 2 equations with 2 variables? Haven't you done that graphically? Graph 2 lines, see where they intersect, right? That's what this is. But this is 2 lines in x and y instead of a and b if you want, right? X and y. So that's 2-dimensional graph paper. Problem here is that we're going to have 3 lines in 3 dimensions. And we don't have 3-dimensional graph paper. So it's hard to solve it that way. All right, so let's solve it this way. Are you ready? How do you solve this? I want to solve these 3 equations for a, b, and c. So you type what command? Solve. Now I'm solving what? 3 equations. So I need to make a list, which means a square bracket. Okay. And just type these equations in. This is 3, right? So I'm going to write 3 equals 4 times a plus 2 times a plus c. Even though we know c is 0, let's Sage figure that out. Did I do something weird? Whoops, b, yeah. Okay? Then what should I type now? What is that? Wait, I got something weird here. There it is. And we're going to have to var because we're solving algebraically, and Sage only knows how to solve algebraically with x, so you have to tell it to var what then? All right, let's do that. Var what? Var, open parentheses, what? ABC, but you got to put that in quotes separated by commas, right? That's how that works. Okay. All right, so that's one equation. Now what happens after you write one equation? What do you type? Comma. Now what's the next equation? ABC equals a plus b plus c equals 1. So write 1 equal. The order doesn't matter. I could write a plus b plus c equal 1 if I want. But I'm writing it exactly like I got right here, okay? 1 equals a plus b plus c. Okay, one more. What? 0 equals c. All right, now what do you need to write? What do you need to type? Not quotes. Huh? Wait, before that, I gotta close the list. So square brackets, right? Comma, and then a, b, and c. A, comma, b, comma, c. All right, and then close the parentheses for solve, and let's see what we get. All right, so c is 0. We knew that. A is a half, and b is a half. So what did we get? We got 1/2 of n squared plus 1/2 of n plus 0. All right, let's write that. Let's see what that looks like. N squared divided by 2 times a half, right? Plus n divided by 2, or b times a half. Oh, it doesn't know n either. All right, let's throw in an n here. Okay, oh, I need a show. Okay, show this one and show this one. All right, so that's the answer. That's the sum. But is that what we had? Remember, we knew the answer already. Is that the same as that? Is that the same as that? Is it? How do you know? How would you make this look like that? You'd have to do what to this? Factor it. Factor out what? N, in fact, n over 2 if you like. But if you factor out n, what's left? Take out the 1/2 and take out the n, what's left? You take out the n, you take out the half. What should be left? Is it? All right, let's make Sage factor it. How about this? Let's see. Dot factor. There you go. So you know this rule, right? Because that's how you add up an arithmetic sequence. It's how many times the average of the first and last? Well, guess what? We got it this other weird way, right? So now we can do this other weird way for the one that they gave us, which was more complicated. We're going to do the same thing. Who's stuck? Anybody stuck on anything? Okay. Well, where's the syntax error? It might be in the line beforehand. I don't know. Put a hashtag there. Hashtag shift 3. Yeah, and just run it again. See if the error isn't on the line before. Just run it again. You click? Okay, I don't click. Yeah, so it is in the line before. Show the solve of 3 equals 4 times 8 plus what? Yeah, but that's still, yeah, there's no n in this line, so that'll be a problem later, yeah. 3 equals 4 times a plus 2 times a plus c, right? Comma. 1 equals a plus b plus c, comma. 0 equals c, right? Yeah, don't close it here. That's this close out here. No, there. So you got it already. And that's better. Okay, now get rid of that and see if we're okay now. And you are. Good. Right?
What is equal?
That's equals is either true or false. What solve does is it figures out what a, b, and c have to be to make those equations true. So that, like, if you check your work, you plug it back in, they work out, right? Okay, who else is stuck? Unsupported type. Oh my God. Well, yeah, because to factor out an expression with n in it, you have to make n a variable. Put a comma n after the c. I think I have that right. Yeah. Yeah, because I had the same problem. There you go. Good. All right, so does everyone have those two outputs? The same two outputs? That's good, right? Okay. Now, realize what you're doing. Since c is 0, I'm really solving a plus b is 1, and 4a plus 2b is 3. Don't you know how to solve that already? Without all of this rigmarole? Let's see if we can do that. Let's see, let me write that. Let's do this the hard way, all right? 3 equals 4a plus 2b, and 1 equals a plus b, right? All right, let's do this on the smartboard for a second. Smartboard, where are you? Come back. There you are. Come on, smartboard. No. Wait, this is not lined up. What the heck is going on? Come on. Oh, that's better, okay. Is this lined up? This is not even lined up. Well, let's see if we can get away with this. All right, here we go. So I'm solving this for a and b. 3 equals 4a plus 2b, and 1 equals a plus b. Now you could do this already. You know how to do this. I know you've seen this somewhere, right? Can you do this by elimination, algebraically? Can you get the b's to cancel or something? Just solve for a. Have you seen this? Multiply the bottom by, no, not by the top. Multiply the bottom by what to get the same number of b's so they cancel? By 2. So if I multiply the bottom by 2, what happens? I get 3 equals 4a plus 2b, and then what do we have here now? It's new equation. Distribute the 2, so 2 equals 2a plus 2b, right? Okay. So what if you subtract the bottom from the top? All right, and what's left? 1 equals 2a, so a is 1/2. Isn't that what we got for a? In fact, they were both 1/2. Wasn't a a half and b a half? How do you get b at this point? Say you didn't know it. Plug it back in. So if a is a half, and you want to get b, subtract the half from 1, and it's got to be a half, right? So they're both a half, right? Couldn't you do this graphically? Even without a sage. You know how to graph lines, right? Isn't this a line? Let me write it this way. 3 equals 4x plus 2y instead of a and b. And 1 equals x plus y. How do you graph this on regular graph paper by hand, pencil and paper? You got to get y alone, and you're going to get mx plus b stuff, right? How do you get this y alone? So y equals negative x plus 1. I wrote it in that form on purpose because now m, you see it, is who? Negative 1, and b is positive 1. Okay. All right, how to get this y alone? Same thing, so subtract. So negative 4x plus 3 is 2y, and then? So negative 2x plus 3 halves is y. Graph that? Do you know how to graph that by hand? Okay, let's do so. Whoops, come back. All right, so I'm going to graph this guy. All right, so what is it? It's negative x plus 1. So how do you graph that? You start at 1 on the y-axis, because the y-intercept is positive 1. The slope is negative 1, right? So I'm going to start at 1 here, and then how? Ugh. This may not come out too good because it's not lining up. And this means down 1 over 1, right? A slope can always be written as a fraction. Negative 1 is really negative 1 over 1. So delta y over delta x, down 1 over 1. I'm here. So this line, oh, not bad, okay. All right, so that's what I graphed. Y is negative x plus 1. So now let's graph this guy. How do you start that one? At who's b? M or b? I need b. 3 halves, right, which is 1.5. So if this is 1 and this is 2, it's starting here. No. Here's 2, here's a half. Pretend. And the slope is down 2 over 1. So down, okay, so from 1.5 to 1/2 to negative a half over 1. Somewhere around there. Connect the dots. And there's your point of intersection. What do you think it is? 1/2, 1/2. Now it's hard to see here, but that's what it is. You can always plug them back in and check, right? Okay, so, or you could do this graphically on Sage, couldn't you? Let's see, what do we get? We had this turns into y equals negative 2. What is wrong with this marker? Y is equal to negative 2x plus 3 halves. And this one turns into y equals negative x plus 1. And where did my plus 1 go? Okay. Oh, and I didn't label this guy. This guy is y equals negative 2x plus 3 halves. Just label each line, right? And the axes, and the origin. Label everything, right? Okay, there's a complete graph. All right, could we do that graph in Sage? Haven't we done that? Okay. All right, let's do that in Sage. All right, so if you want to do this graphically in Sage, you're going to take what we have, y equals negative 2x plus 3 halves, and y equals negative x plus 1, and you're going to do a what command? A plot. Okay, how do you plot more than one function? I'm plotting 2 lines, right? So you need to make a list. How? Square bracket. Now remember, the plot command, you don't have to say y equals stuff, you just say the stuff, right? So negative 2 times x plus 3 halves, right? Comma, negative x plus 1, was it? Yeah. All right, and let's see if that's enough. Does it look like it hits at x equals 0.5 1/2, which is 1/2, and y is 1/2? Here you have to eyeball this. If you had a graphing calculator, you could actually do a second calc intersect and get it more exactly, right? But we already got it, right? Didn't we get the 1/2 1/2 when we called it A and B? All right, so that's my version of 8, an easy version of 8. Are you ready for their version? Let's do it. All right, let's go to this 8. They want you to prove this. They don't tell you this. I'm telling you this, but that's basically what they want you to do. All right? So, what do? Well, since we're looking for 1, 2, 3, 4 terms, I'm going to plug in 0, 1, 2, and 3, right? Before, I plugged in, what did I do? I plugged in 0, 1, and 2, right? But I need another equations. I'm going to plug in 0, 1, 2, and 3. All right, let's do that. So if n is 3, what does that mean? I'm adding up 3 things, right? All right, so add them up. How much does that add up to? This is 14? Okay, 14. Equals. And then plug in 3. Well, all right, what's 3 squared? 27. So I'm going to write 27a. Okay, what's 3 squared? Sorry, I meant 3 cubed is 27. What's 3 squared? 9. So plus 9b. Okay. Plus, well, what happens when you plug in 3 now? 3c. There you go. Plus d is just plus d, right? All right, I plugged in 3. What am I going to plug in now? 2. All right, which means I'm adding up how many? 2. So how much is that? 5. Okay, so put 5 here equals. All right, now plug in 2. What's 2 cubed? 8. So I got 8a. What's 2 squared? So 4b. And then plug in 2, you get what? 2c. And the plus d is always tagging along. Okay, this is what we did yesterday. I don't know if you realized that. I plugged in n is 2. I plugged in n is, I plugged in n is 3. I plugged in n is 2. I'm going to plug in what? N is 1, which means I'm adding up how many terms? 1, which is only this, so 1. Okay, good. Equals, all right, what you get when you plug in n equals 1 over here. So plug in 1, plug in 1, plug in 1. What do you get? A plus b plus c plus d. All right, one more. We plugged in 3 for n, 2 for n, 1 for n, so 0 for n, which means I'm adding up none of this, so I get, well, wait, but what does it add up to if I'm adding up nothing? 0 equals d, okay. All right, and that makes life easy. All the d's are 0 already. But can you do this graphically? Do you know how to graph in 3 dimensions? If we do this on graph paper, we're going to say x plus y plus z equals 1. 2x plus 4y plus 2z equals 5. Do you know how to graph that? You could graph that in 3D, but you need 3-dimensional graph paper. Yeah, that's sort of hard. So we're not going to do it that way. We're going to do a solve command. Okay, so let's do like we did before. Now, we have vars for a, b, c, and n. What don't we have a var for now that we need? D. So var d and solve, just like last time. Okay? All right, so solve. Okay, list. All right, I'm going to start down here. 0 equals d, comma. Then I'm here. Yeah, okay. Or half the class is injured, huh? All righty. All right. All right, so I'm going to write 1. Whoops, not there. 1. Hello, get down there. 1 equals a plus b plus c plus d. And 5, do you see what I'm doing? I'm just copying. 5 equals 8a, 8 times a. You got to do the explicit multiply, right? Plus 4 times b plus 2 times c plus d, comma. And then the last one is what? Oh, what did I forget over here? Equals. And then the last one? 14 equals. All right, 27 times a plus 9 times b plus, 3 times c plus d. Close the list, comma, tell it what to solve for. Well, I could just tell it to solve for a if I want. There is no solution. Wait, we had an answer yesterday. What did we do wrong? I don't like that. All right, open parentheses, a, comma, b, comma, c, comma, d. Close that parentheses. What do you got? Okay, that's different. All right. So we knew d was 0, right? We knew that. But now a is a third, b is a half, and c is a sixth. So if a is a third, you got n cubed over 3, or 1/3 times n cubed. If b is a half, you got 1/2 of n squared, or n squared over 2. If c is a 6, you got 1/6 of n, or n over 6, and d is 0. Let's write that out. Let's see, I'm going to write it out make this a little smaller so it fits. Okay. I'm going to write it out right here. I'm going to say, what is it now? N cubed over 3 plus n squared over 6, no, over 2, plus n over 6, and that's it. Alrighty. I probably want to show here. And the show here. Ah, what? What'd I do? Oh, the S went away. All right, so that's what I got. Is that what they want? This is what I got. Are they the same? Not unless you factor. Okay, so let's factor that. You could put a dot factor at the end or put it in a factor, I think. So let's do that. Put factor of that. Either way. Did you get that? 1/6, there it is. N times 2n plus 1 times n plus 1. There you go. Perfect. That's what they wanted. Now, this is hard to do graphically because you don't have 3D graph paper, but I think there's a way to do this in Sage. I wonder if I could do it in Sage. How do I do that? Well, remember, when we plotted the other ones, we had to get y alone, right? Now we got to get z alone. Yeah, that's more complicated. We don't have any time. Maybe, or we'll finish this. We're done as far as their question is concerned. But I think I want to come back to this again on Monday. All right, but that's it. We're done for now. Right? Aren't we out of time? Yeah. All right, but that's it. That's what I was trying to do yesterday. We sort of rushed it. Does it make sense now? Better sense? Okay. For that matter, couldn't you add up the first n perfect cubes if you wanted to and get a rule? You could do that now, couldn't you? All right. Whoop, Blake, what? Stuck? What happened? When did it die? Did it do the first show okay?
Yeah.
No?
This show. Yeah, it did that.
It's not doing this one.
Well, it did that.
It did, really?
Yeah, and then I plugged it in and it's not doing it.
Where's mine? I have 3 closes here. Did you lose one? Yeah. Okay. There you go. Good. Yeah. All right, save it. All right, so we'll come back to this a little bit more next time. We're almost done. We are done as far as they're concerned, but I'm going to talk a little bit about it. Have a nice weekend. All right, see you Monday. Rest up those brain cells for the hurricane. It's not going to hit until late Monday. It might stick around through Wednesday. But it's huge, and it's slow, but it's going to be weak. Yeah, so. All right, anyway. Not like last year. Yeah, we had an earthquake in August. We had a hurricane, and it was pretty bad in September. And then we even had almost like a blizzard by Halloween, didn't we? That was crazy last year. All right, so that's done. Leave that there. Oh, look at that. Well, that's what the CD looks like when you boot it, right? Yeah. Yeah, I know. That's why I don't do virtual anything. I like the speed. Oh, because of that. Okay, but there's. You don't have a lot of lag at home then? Okay. That's good. All right. Bye-bye, YouTube.